Okay, so last time, the last video, we did hypothesis test for mu, the population mean. We also stuck on the confidence interval from test 3 that relates to it. Now we have to do the proportion. This is just like our camps that we had to deal with on test 3. How are you going to know the difference between the camps? It's the exact same thing from test 3. If you're given mean and standard deviation, or you're given a data set, then it's a mu problem. If you're given fraction or percent, 43% of 150 people, something like that, you know it's a proportion problem. So again, you can either print the notes or take notes as we go. P, the population proportion. It is always helpful to have your CI chart out and your cheat sheet. So let me remind you again on the cheat sheet. Okay, so confidence intervals. Those two were test 3, but they are going to be back on test 4 because they support our hypothesis test. The last video, we did the mean. So just to let you know, in just a second, I'm going to put this on the board. Here is the information for the proportion hypothesis test that we're doing today. So instead of mu, we have p equals some proportion, 0.5, 0.6, 0.8, a number less than 1. Well, I don't know why I'm writing that. Sorry, I'm getting ahead of myself. Just like when we did with confidence intervals. You know, the mu problems had t's in them. The p problems had z's in them. Same thing holds here. We are back to that the test statistic is a z value. Okay, so this beginning part is on the cheat sheet. Our sample proportion minus the hypothesized value. The hypothesized value is what is used in there. On your calculator, for intervals, we used to go to 1 prop z int. Now we're going to 1 prop z test. So the calculator shortcuts are very similar. They're named in a similar manner. Here is your normality assumptions. Please notice this is the hypothesized value up here, not p hat. Think back to handout 9, sampling distribution. There was a p there, right? So in hypothesis testing, we're saying let p equal that number until you prove otherwise. So your normality assumptions, we're assuming that p is whatever number is right there. Because I do stick on confidence intervals, after hypothesis test, I want to point out something. Your calculator already knows to do this, but this square root term, I want you to notice that the square root term for the confidence interval is different than the square root term for hypothesis testing. Confidence intervals don't assume anything is true, so the only thing we can use is the sample, the p hat. Hypothesis test, we assume p is p naught until you prove otherwise, so there's a p naught in there, so you can't just steal the same number. Those are different values. All right, Again, pause the video because I want you to read the beginning of handout 15. It's very handy if you have a blank copy in front of you that you can fill in as we do it on the whiteboard. Okay, so disclaimer, I made up the numbers for handout 15. I do think that number for America is correct, but the information I give you about Alaska, I completely made up. So please don't think that this is the truth about Alaska. I actually think maybe the most obese state in America is either Mississippi or Alabama. I've never heard anything about Alaska. But anyway, this is another one that was similar to the sewage problem in that it seems like it's talking about two different things. Maybe I should back up for a second. Just by scanning the problem, there is no mean and standard deviation, and there's not a data set. So it absolutely is a proportion problem. Okay, now let's just kind of summarize what they've got here. They're talking about America, and they're saying 68% are overweight. Remember, anytime you have percent, you have to change them to decimals. We will assume this info came from a census of the population. They are trying to tell you we know the truth about America, meaning we're not running the hypothesis test on America. If you want to know what America is, I'll tell you right now, it's 0.68. What are we unsure of? Who are we clueless about? What are we trying to collect data on so we can make a statement? That's Alaska. Suppose a dietitian from Alaska wishes to know whether proportions differs a sample. Okay, 500 of 600 Alaskans, I think Alaska's AK, are overweight. That's my sample information. Let me highlight that. If you want your p hat, it's 500 out of 600, which, just so we can talk about it, 0.8333. So there's your sample proportion information. I sort of, on purpose, skimmed over where the question was. It says, is Alaska different from America? This is the first time we've had a not equal hypothesis test, which is going to make us have to add something to step 4. The problems we did on the last video, I think they were both just less than problems. This is the first time we've had a not equal. This is called a two-sided hypothesis test. We'll figure out what to do with that in just a minute. But we can go ahead and set up your HO and HA. Oh, maybe I should write down that they did give you alpha. Now, also, let me point out, I'm going to ramble about this problem for a minute because whether I'm right or wrong does not matter. I want you to get an idea of, wait, what am I trying to figure out? Alaska's sitting at about 83%. America's sitting at about 68%. We're trying to figure out if that is a significant difference or if it's just random variability. Like, if Alaska was 70%, 70 to 68, in my opinion, I'm probably going to think that's possibly just some random variability. We would still test it, of course. It just seems like to me that 83% is significantly different than 68%. But again, it doesn't matter what I think. That's why we're doing the hypothesis test. Let's start this at part A. I have lost my black pen. Oh, get a different one. All right, set up the hypothesis. The question goes into HA. Is Alaska different from America? But we know what America is. America is 0.68. Is Alaska different from America? We're just translating words into mathematics. HO is always equality. Part B, you need to state what that P is. Now don't say the word mean anymore because we're on proportion. P is the true proportion of overweight Alaskans. That's who we're clueless about. That's who we took the sample on. That's what we're trying to test. We know the truth about America. How do we know we have normality? N 0.68 greater than or equal to 15 and 1 minus 0.68. We're totally good there. We're okay on normality. All right. I want to start a picture. Again, picture's not required from you. But really what I'm trying to figure out here, did 0.8333 come from this curve or not? Obviously 0.8333 is going to be up here somewhere, right? I just don't know where yet until I do step 3. This is the z-score, the exact definition that we've been doing. P hat minus hypothesized value. Remember, sorry, the formula's right there on the cheat sheet. We've got to go to our calculator now. So go to Stat, move over to Test. Very similar to what we did on Test 3. One prop Z test. Hit Enter. It's going to look very similar. Since we're doing the test, it is going to ask you what is your initial hypothesis test number, 0.68. This one's nice and easy. Remember the XN stuff that we had to deal with on Test 3? I like that this one gave it to me in fraction form. It said 500 out of 600. So your X is 500. Your N is 600. This is a not equals. I'm trying to get this in the light for you. Make sure you select the not equal button. Then hit calculate. Oh yes, I forgot that this one turns out like this. The Z value is 8.05. Actually, knowing what you knew from test 2, you should already know everything you need to know about this problem. You know where a z-score of 8 is. Remember that was off our chart? So we actually know that a z-score of 8.05 is way up there. Now remember what the p-value definition is? Where I land more into the tail, we already know there's basically nothing past 8.05. This, I gave you one on test 2 just like this, and if it had said greater than, your answer to 4 decimal places is 0. So we already know that the p-value should be 0. Let's make sure we don't make a mistake when we look at our calculator. We need the p-value expression. Oh, well, hold on. I have so many things I want to say, I don't know what I want to say first. Okay. The last video, we had less than symbol, and then we got a negative test statistic, which then we wrote less than the negative. Well, this one's different. We landed up here at the positive test statistic. So the p-value is actually greater than. That's how I knew that I have a greater than symbol here. See, the greater than symbol always goes with the positive test statistic. The less than symbol would go with a negative test statistic. You're either always going to be doing greater than the positive, or you're going to be doing less than the negative. So this one is greater than positive 8.05. Why am I saying this 3 different times? Because see, that symbol does not help you in part D. You are not allowed to put the not equal symbol here. That has absolutely no meaning. When this is a greater than or less than, you should be able to use it right there. But this is a not equal. So you're going to have to think about which symbol you need in the p-value expression. Those small details I do take off for on test 4. Now, the next minute is new for you. What is different when you have a not equal? Well, basically not equal says if you're too big, if you're way up here, I don't think you came from the curve. Or if you're too small, if you had landed way down here, I don't think you came from the curve. Not equal really indicate there are 2 cliffs that you could fall off on of my mountain. But we only got 1 sample, so of course we can only land in 1 spot, right? So how do we take care of that? You're going to need a 2 times in front of this expression. Anytime you have a not equal, you have got to just put 2 times in front of it. When you tell your calculator you're doing a not equal, it already knows to do that. So you're not actually going to multiply what's on your calculator by 2. But your calculator figured out what this is, then it multiplied it by 2, and then it spit out the answer to you on your screen. Okay, but that's usually worth a point, so you don't want to lose easy little points. And this 2 is just indicating that there would have been 2 areas that if you had landed in it, I would have said, I don't think you came from the curve. I think you're different. Now, here's another spot that I see students make probably 3-point mistakes. We went through this, I don't remember if it was test 2 or test 3. I think it was test 2. So plain old P. I have numerous students try to tell me that the p-value is 8.25. That is literally impossible. Remember, p-values are areas. They have to be numbers less than 1. Make sure you look at the entire screen. It's 8.25 e to the negative 16. Maybe I should write that. It is not 8.25. It's 8.25 e to the negative 16. Remember, I do not accept scientific notation, so I need you to show me that you know that the p-value is approximately 0. What's my next step? I have to compare that to alpha. Alpha is 0.05. Is 0 less than or equal to 0.05? Of course it is. It's 0. Doesn't get any better than that. So yes, reject HO. There is evidence of whatever they asked me. I need to come up higher. So p-value is less than or equal to alpha. Yes, we're rejecting HO. There is evidence the true proportion of overweight Alaskans differs. You can say differs from 0.68. You can say differs from America, if you just want to go steal from the original question that they asked. See, here's the problem. Okay, fine. I've learned that it's significant that, yes, Alaska is different from America. But maybe I still want some idea about where is Alaska falling. You know, is it up in the 70s, 80s, 90s, whatever. So that's why we stick a confidence interval on at the end. We need a 90. So this is part of your sheet, F and G. So P hat, plus and minus. Now remember, the confidence interval formula has the p hats in it. So this square root term is not supposed to match your part C. And I cannot read my own handwriting. 0.83 times 0.17 over 600. Before we go to the calculator, let me point out something. Remember, this comes off the CI chart. A really big mistake on test 4 in the exam is students think that the z-score there has something to do with the hypothesis test. It absolutely does not. You are not going to pick up the 8.05 and putting it there. That is totally wrong. This is a number that is set. It doesn't matter which problem we're doing. All we care is that it's 95% and it's the z value. Okay, so that's test 3 information right there. Now that we've already typed in everything for one prop z test, this should be very quick. You need to go find one prop z int. When you get there, everything's already going to be typed in. You just got to put in the C levels 95. And then I prompt you in a way to use that confidence interval to answer the original hypothesis test question. And basically says, because remember, this confidence interval is for Alaska. And the question was, is Alaska different from 0.68? Is this different from 0.68? One way of saying it, we're getting the same conclusion. We're still rejecting. We're still saying there's evidence of a difference since 0.68 is not in the CI. I don't know if you remember on test 3, handout, I don't remember. It was about pulse rates of Penn State men and women. And it was the unusual problem that just said test if it's 72. And we talked about how you didn't have to talk about the entire confidence interval. You were just looking to see if the number was within the confidence interval or not. I think we called it our could it be's. This is why those types of interpretations for the confidence interval, just could it be 0.68 or not, supports our two-sided hypothesis test. All right, let's do one more problem. Technically, it's handout 18. You do not have to have it out because handout 18 is so short that I can write the problem up. "26% of 143 students like hamsters. Is there evidence more than a quarter like hamsters? Alpha is 0.05. If I hadn't told you that, technically you could have solved it using a confidence interval, but I will prompt you to go through all 5 steps of hypothesis testing, so it would be really hard to miss that I want you to do hypothesis test, because I should have pointed it out. Handout 15, see, I've talked you through the steps. You do not have to memorize the steps. Just when you read the step, you have to know what to do for that step. But this is pretty much exactly how your test would look. All right, so let's make sure we know. This one is percent form. So I immediately know what my p hat is. I know my n is 143, alpha is 0.05, and where is the question? Because the question is going into HA, right? More than a quarter. Hopefully you know that a quarter is 0.25. I know I'm sitting at 0.26. I also know that, yes, that is technically more than 0.25, but that's probably just random variability. I have to let my cat out of my room. Hold on. All right, so let's set up our HA, because that's what we set up first, right? Is there evidence more than a quarter? That's the question. So HO is equality, where P is the true proportion of students who like hamsters. Right? I know that 26% is for those 143. I'm trying to make a statement about all students, the true proportion, the population proportion. Normality, P naught, that one's fine. This one is fine. You have to check that as part of part B, our 5 steps of hypothesis testing, every single time. Now, again, just that running picture to try to help you understand conceptually what we're doing. We're trying to figure out if it came from a curve at 0.25 or something bigger. Now, I do know that 0.26 is over here somewhere. I just don't know where yet until I do step 3 or C. And I get my z value. P hat minus hypothesized value. You've got to make sure you put these in the right spots, or else it's going to mess up everything on the calculator. Now, this is one that I know some of you struggled with on test 3 material and probably even on the test. Go run your one prop z test. Now, P naught is 0.25. But remember, this problem didn't give us x. We have to calculate x. We have to calculate what is 26% of 143. So I'm going to type in 0.26 times 143. Okay, I'm going to hit enter, and it is a decimal. If you try to calculate right now, you're going to get a dimension error. So you have to go back up. 37.18 should be rounded properly to 37. N is 143. I am doing a greater than. So that's what your calculator input should look like. Then hit calculate. You're going to get the z-score of 0.24. 0.24. Wow, I'm going to have to exaggerate this one. This is only 1/4 of one standard deviation above the mean. It's not even a half a standard deviation. That's very awkward. It's 1/4. It is probably as close to the middle as you can get. This is a z-score. Now, so please don't let that confuse you. This is not a proportion. That's why I've got 0.24 being bigger. Remember the 0.25, this was your P. This is a z-score. Unfortunately, these numbers are so similar that I can imagine that's going to confuse people. How is 0.24 bigger? This is z, this is p. You can't compare those two, right? This is like z value of 1, z value of 2, z value of 3. So he's just a little above the mean. Oh my God, he's fitting my curve perfectly. I can tell you right now, we're not going to reject. Remember what the p-value is? Where did I land? More into the tail. That's a picture of the p-value. Let's do some of our checks and balances here since we can. We were doing a greater than problem. You better come up with positive, which we did. And that feeds into my part D. The p-value is the probability that z is greater than this positive number. Look at your calculator to see what is that black area. P-value is 0.405. That's your p-value. I gotta come up higher. Now we have to compare. Is our p-value less than or equal to alpha? I don't remember if I gave you alpha on this problem. If I put it on the whiteboard, it is on the notes. Alpha was 0.05. No, 0.405 is not less than 0.05. Do not reject HO. Yeah, because you're fitting my curve just fine. There is not evidence of what was asked. There is not evidence more than a quarter of students like hamsters. All right. So now we've done 2. Now it's going to be your turn to practice some homework. This ends the hypothesis test for 1 sample problems. We've done mean and proportion. The next couple of videos are about 2 samples. The steps are going to be the same. Some of the formulas are a bit longer. It takes a little more thinking, so you have got to get really good with the 1 sample problems. And if you do, then the 2 sample problems are going to come much more naturally. So make sure that you don't just keep pushing ahead watching the videos, that you practice the homework before you go on to the next video, just like we would do if we were in the classroom together. So you can redo handouts 15 and 18. On handout 17, do 1, 3, 6, and 10. On handout 19, do 3 and 7. And again, answer keys for handout 17 and 19 are in the test 4 module. Get really good at that stuff, then you can start watching the videos for the 2 sample problems.